Thank you for introduction. I'm Nakatsuma from Kumamoto University, Japan. Today, I introduce a novel sensing technique to measure human-to-human skin contact area precisely. My research motivation is the importance of skin contact between humans. For example, between mother and baby, or for age care or for health care. Touch, so physical contact between human to human is considered as an important factor. And there are a lot of researches about this touch efficacy. And in engineering field, many researchers approach as engineering technique to use this potential of human-to-human skin contact. For example, this robotics therapy, or this using this haptic device. Researchers try to support the touch therapy of aged people, or people who have autism or mood disorder. As I mentioned above, touch efficacy is widely recognized in medical, psychological, and engineering fields. However, current research about touch, so physical contact efficacy, is basically based on questionnaires or the observation. So there is no quantitative evidence. So my research is challenge this problem. So my research goal is quantifying the skin-to-skin touch activity, and typical application is experimental experimental study of touch in medical or psychological fields. The human-to-human skin contact is very complex phenomenon, and there are a lot of physical factors which is related to the touch activity. And today, our target is contact area. So when two people touch each other, we'd like to take the how large area they touch. And when there are some physical contact between skin and object, or between object and object, there are a lot of sensor systems to detect the contact area. For example, haptic or tactile sensor, or touch interface like iPhone or iPad. However, there is no technique between skin-to-skin contact area. So we consider there are two approaches to detect the skin-to-skin contact area. One approach is using wearable sensor, and one approach is using some external sensor like camera. And we employ the wearable sensor technique today. Sorry, I skipped this slide. Our approach is very simple. By transferring some physical information from one person to another person. The information will be acoustic wave, so elastic wave or electric signal. And today's sensor employing the acoustic wave. when two people touch each other and transferring the acoustic wave through the through this through two people's body, the inner body transfer function of each person will be not changed. However, the transfer function between two touching people, so here the H12 will be changed depending on contact condition. To realize this approach, we developed this sensing system. To simplify the problem, we limit the contact area on palm. I'm sorry. So in our system, one person wears a vibrator on the wrist, and another person wears a vibration sensor on wrist too. And vibrator, when vibrator is active, acoustic wave, so elastic wave, is propagates through the body, and the sensor detects the vibration wave from the vibrator. And when the touching area, so skin contact area, increases, we consider the sensor detects more and more vibrating power. And this is our prototype. This is the vibration part. We use eccentric motor like this. So the diameter is about 10 millimeter. And 4 eccentric motors is attached on the wrist. And we designed these motors. These motors vibrate at 200 Hz. And this is the design of our vibration sensor. We utilize microphone and silicon tube to capture vibration on the skin surface. When the elastic wave from the vibrator is reached to this sensing area, the arm is vibrating, and the vibration on the arm is transferred to the silicon tube. And since the silicon tube vibrating, the inner space of the silicon tube is there will be occur the acoustic wave. Then the microphone detects the acoustic wave as a sound signal. Because the acoustic impedance of the silicon tube and the skin is similar, and the acoustic impedance between of the skin and silicon tube and the air is quite different. The sensor can detect only the vibration on surface of the skin. This is our prototype. Here's a silicon tube and the acrylic cavity and the microphone. We use this silicon tube as a wristband, so the subject can wear this sensor as a wristband. When two people touch each other, the sensor detects the signal, vibration signal, like this. And when the touching area decreases, the detected signal signal also decrease. This is the acquired signal of the sensor. Also, we designed the vibrator vibrates in 200 hertz. The detected vibration wave is 100 hertz. This is because we use eccentric motors, and eccentric motors vibration frequency is changed depending on the vibrator's mechanical stability. And this vibration frequency is around 100 hertz, but not just we cannot control the vibrating frequency exactly. So we use the summation of amplitude from 90 to 110 hertz as an evaluation index. And to detect the reference contact area, we use the ink. We use the approach to use ink like this. And this is our main result. When contact area between two subjects is increasing, the signal amplitude detected at the sensor is also increasing. So by determining the dysfunctional relation between these two factors, we can estimate the contact area from the signal power. And additionally, we try to evaluate the contact force effect. And the blue point is the same data of this main result. And these are the data when contact force is weak, and these red points when the contact force is strong. Of course, it is very difficult to control contact force and contact area independently. But overall trend between contact area and signal power is approximately similar. So we consider that the contact force will be no. We don't have to consider about the contact force effect when estimating contact area, when the touching area is limited on palm to palm. So this is today's my talk's summary, and our future work is first we should stabilize the vibration frequency on some specific frequency, and next we should estimate the contact area from sensor signal. Thank you very much.